Hi everyone, today we're going to continue talking about scatter plots. Hopefully you watched the other two videos. One was about drawing a line of best fit and the other one was interpreting and making predictions based on a line of best fit. We're going to continue to talk about using the line of best fit to make some predictions. So let's look at this. I have scatter plot that shows the years of experience and the income in thousands. Said according to the line of best fit, what is the expected income for a person with 15 years of experience? Well, the line of best fit goes something like this. We have about as many points below as above, maybe a few more above. Goes through several points. So it is a pretty good line. So then if we look at 15 years of experience, it is right here. Draw a line up and then look across. See where it intersects my y-axis. That is about 37, 38. Looking at my choices, it's definitely above 35. It's definitely below 45 or 50. 38 is my best estimate. That would be considered interpolation because it falls within the data points I have. Now let's look at this one. It says, according to the line of best fit, what's the expected stopping distance needed when driving 40 miles an hour? Down here I have speed of the vehicles in miles per hour. Going up my y-axis, I have my stopping distance. Well, 40 is way out here. It is outside of the points I have, but I can still use my line of best fit to make predictions. Go up to my line, look across. It looks like it's somewhere in the ballpark of 90 feet. That would be considered extrapolation because I had to extend my line to find that information because it's not within the data points on my scatter plot. Okay, based on this scatter plot, what's a better prediction for y when x equals 9? 5 or 10? Well, here's my line of best fit. Go out here to 9 and look across. That is about 5. 10 would be way too high. It would be up here. Which point would cause the greatest change to the line of best fit? So to change the line of best fit more, I'm going to have a point that is away from the line. If I had one that was right here, it's not going to change my line at all. But if I have one, way here, it's going to make my line tilt downward. So let's look at the options. I have 3, 0, 3, 0. That is right here. It's not that far off the line. How about 4 and -8? 4, -8, that's way over here. That is quite a bit off the line. I would say that would make a significant change in my line of best fit. Then look at the rest of them though. -4 and -3, -4, -3. That is right on my line. So that's not going to make a change to it. And -2, -2 is also on my line. So I would say 4, -8 is going to make the biggest change to my line of best fit. Which one would make my line of best fit steeper? Well, if I add a point down here, it might tip my line downward. If I add points up here, it's going to tip it upward or make it steeper. So I'm looking for points that would be up here that would make my line of best fit steeper. So let's look. 1, 2. 1, 2. That's up here. That seems like it would make my line steeper. Let's look at the other one. 1, -1. 1, -1. I already have a point there. I don't think that would make any difference to my line of best fit. 2, 0. Again, I already have a point, and this one's right on my line, so it's not going to make a difference. And 3, -1. That will make a change to my line because it is below the line, but it's going to make it less steep. It's going to bring my line down a little bit. So the one that's going to make it steeper would be A, 1, 2, because it's going to be up here. Because a steeper line would go like this versus a flatter line or a less steep line would have a smaller slope. What's the approximate rate of change for this line of best fit? Well, the first thing I'm going to do is I'm going to look at this, and this is a positive correlation. It's a positive slope. So it's not going to be A or B. Those are both negative. Now, some of you might look at this and say, oh, well, first I'm going to put a couple points on here that cross my line so that I can count. And you might go, okay, it's going up 1, 2, 3, and over 1, 2, 3, 4, 5. So maybe 2 over 5. But then I go, or 3 over 5. I think that is 1, 2, 3 over 5. You might pick 2/3. I don't know. But you have to pay attention to the scale. The scale on this, on my y-axis, it's going up by 20. So this would be 20, 40, 60. And this way it's changing by 5s. 5, 10, 15, 20, 25. So it is about 60 over 25, which I can simplify by dividing, oh, that's not 25, divided by 5. Be 12 over 5. Oh, what's 12 over 5? It's more than 1. It's going to be about 1 point. No, it's actually going to be more than 2. 2.4. If I made it into a decimal for comparison purposes. This is less than 1. This one is more than 2. This would be about 2.6. Repeating. So which one's closest? D is definitely the closest one. Paying attention to the scales is really important. It's so easy to just count the numbers. Count 3 spaces over 5 spaces, but you really have to pay attention to the scales. That's it. Have a great day.